Example 3. Use transformations to graph f of x equals e to the x minus 1. So since we're graphing using transformations, we want to first identify the parent function. So if I cover up the minus 1, I'm left with a base of e raised to a plain x power. So I can see that this parent function would be e to the x power, the exponential function e to the x power. So when I list my key points on my parent function, that parent function is going to be e to the x. So I'm going to be comparing my function, e to the x minus 1, to the parent function, e to the x. So remember, our parent exponential functions are of the form a to the x power. And remember, our key points on an a to the x graph are going to be negative 1, 1 over a, 0, 1, and 1, a. So in this case, our parent function, our a value, is the number e, that 2.7, approximately 2.7. So my key points, and again, we don't have to memorize these points, we just need to be able to generate them. If I put a negative 1 in for my x, if I raise e to the negative 1 power, that's going to give me 1 over e. We know negative exponents give us reciprocals. Then if I plug in a 0 for my x, e to the 0 power, anything to the 0 power, is 1. And then my easiest point, if I plug a 1 in for x, e to the first power is just e. So there's my 3 key points on my parent function. Now we know an important feature of exponential functions is the horizontal asymptote. So we know that these parent exponential functions have a horizontal asymptote at y equals 0. So when we do transformations, we need to consider any transformations that will happen to that horizontal asymptote. So if we go back to our equation, our parent function is e to the x, and then we're subtracting 1 from it. So since we're subtracting and we're outside of the grouping symbol, now when you're dealing with exponential functions, remember your grouping symbol in this case is actually the exponent. So if something changes up in the exponent, that's a horizontal change. This minus 1, though, is not up in the exponent, so it's not in the grouping symbol, so it's going to be a vertical change, and specifically a vertical shift down 1 unit. So we have a vertical shift down 1. So we're going to take our 3 key points here, and we're going to subtract 1 from these y values. So I'm going to leave all my x values of my key points the same, the negative 1, the 0, the 1, and I'll subtract 1 from all the y values. So if I take 1 over e and subtract 1, that's going to be the exact value. Now when you go to sketch the graph, you're going to want to get a decimal approximation, but for now we want the exact value, 1 over e minus 1. So now, if I take my y value of 1 and subtract 1, that will give me a new y value of 0. And I take my third y value of e and subtract 1, and that gives me e minus 1. Again, we leave the exact value, e minus 1, in our table, and then when we go to sketch the graph, we'll use a decimal approximation. Now, if we're shifting this graph down 1 unit, that horizontal asymptote will shift with it. And you can also just look at it as this is saying y equals 0, subtract 1 from it, and that will give you a new horizontal asymptote of y equals negative 1. So when we go over onto our graph, we'll sketch our axes here. So I'm just going up 3 units each way, up and down, right and left. So now, when I go to sketch my key points, we know that 1 over e is approximately 0.4. You can verify that in your calculator. So if we do 0.4 minus 1, that's going to give us approximately negative 0.6. So when I go to plot this point, I'll go to x value of negative 1 and then go down negative 0.6. So somewhere between 0 and negative 1, about halfway between. But I do want you guys to label that point exactly. So we want to label it negative 1, 1 over e minus 1. Now we've got our second key point, 0, 0. Again, label that point 0, 0. And then we've got our third point is 1, e minus 1. So we know e is approximately 2.7, so 2.7 minus 1 gives us approximately 1.7. So we'll go to plot this point, x value of 1, and go somewhere here between 1 and 2, a little closer to the 2. So here's my third point, 1, e minus 1. And then we've got to sketch our horizontal asymptote, so that boundary line down at y equals negative 1. And then we sketch these points, and we know that this swoop or ramp shape, it's approaching that horizontal asymptote. So as you sketch this, make sure it looks like it's flattening out here. As x gets smaller, as x approaches negative infinity, make sure that ramp shape looks like it's approaching that horizontal line, and it will not cross that horizontal boundary line.